Welcome back to your second lesson of personal finance. Last class, we discussed setting the foundations of our financial plan. We figured out our current financial position, came up with a few financial goals that we would like to accomplish, and finally developed a plan to get us from where we are now to where we want to be. Today, we are going to go behind the scenes to understand why this plan works. And then, next time, in the investing lesson, we will discuss how specifically to implement your plan. In today's lesson, we will learn about interest rates, interest, discuss how banks determine credit readiness, and examine how the value of money changes across different periods. Finally, we will use this skill in order to examine how we should begin to look at retirement and calculate our retirement need. As a general rule, money is more valuable now than it is in the future. The rationale behind this general rule is rooted in the concept of opportunity cost. If you have money in the present time period, there are many options and different investment vehicles that you can choose to allow your investment to grow. The longer the investment, the larger the possible growth due to compounding interest. Remember from the economic growth lesson we learned how the GDP per capita in Western countries and sub-Saharan African countries diverged due to the power of compounding growth. Similarly, compounding interest, or the ability to earn interest on previous interest, is the strongest factor in the growth of an investment portfolio. This is why even the great Albert Einstein believed in the power of compounding interest. Is it incredible to think that if you invest $1,000 right now, in 20 years, 55% of your wealth would have accrued due to compound interest? Now that we know why there is such a difference between value in different time periods, let's see how we actually calculate it. We can move money from the present to the future, which is aptly called compounding, or from the future to the present, called discounting. In order to calculate what a monetary sum will be worth in the future, we use the formula of future value equals present value times 1 plus I raised to the time periods. This is equation 3.2 in your book. In order to calculate what a sum of money is worth in the future, we simply take the value in the current period, multiply it by 1 plus the interest rate, taken to the power of the number of periods. In order for your calculation to be accurate, you must match the period of the interest rate with the type of period in the exponent. For example, if it is a monthly interest rate, the number of periods until the future must be in months, while if it is an annualized rate, it must be in years. It is fairly simple to convert from an annualized interest rate to a monthly interest rate. Simply divide the annualized rate by 12. Converting monthly to annualized is slightly more difficult. In order to account for the multiple periods of compounding, you must add 1 to the interest rate and take it to the 12th power. Then subtract 1 and multiply by 100%. Let's try an example. If we are saving for an intermediate goal and we decide to save $1,000 at the start of each year for the next 3 years in a saving account that pays 6% annually, how much will we have saved immediately after our third deposit? This is actually a 3-part problem because each of these present values needs to be transferred into year 3. So first, let's start with this year's payment. $1,000 is our principal, 6% is our interest rate, and we raise it by 2 periods because our third payment occurs at the end of the second. 1,000 times 1.06 raised to the second gives us the future value for this payment. We then must calculate the future value of the second payment. 1,000 times 1.06 raised to the first. Finally, the last payment is already in year 3, and therefore the future value of that payment is $1,000. If we sum these up, we find that after the third deposit, we will have $3,183.60 in our bank account. What about finding the current value of payments that will occur in the future? To calculate this, we simply rearrange the formula. Let's try the classic example of winning the lottery. If you win the lottery and you must choose to accept a lump sum now of $2 million, or you can receive 4 payments as outlined on the slide, which would you choose? Before today, many of you would think to add up the total payments and find that $3.25 million is an entire $1.25 million more than $2 million. But now we know better. This is probably not the best way to do it. We do not need to discount the initial $250,000 because it is already in the current time period. After discounting the other 3 future millions, we can see that the million 5 years from now is worth $747,000 today, while the million 15 years from now is worth only $417,000. And the total of $1.97 million is less than $2 million, and therefore you should take the lump sum. Let's work through another example in Excel. If you are planning to save for an investment goal of $5,000 in 2 years and you expect to receive 5% annual return on your investment, what should you do? What if you decide to save $200 a month? Will this be enough at the end of the 2-year period? Because you are making continuous contributions for a set period of time, this is called an annuity, which follows this formula. There are many ways to calculate in Excel, but today I will show you only 2. Both of the skills will be paramount to your successful completion of the personal finance exercise. The first is to maintain an account balance through the 2 years. Due to the copy and paste functions, this is relatively easy. First, we must convert our annual interest rate into a monthly interest rate by dividing by 12, and the number of years must be multiplied by 2 to find the number of months. We will start in month 1 with a deposit of $200. The deposit plus the starting balance will find our principal. Because we just put the money in, it will not accrue any interest in month 1. Then the ending balance is simply the sum of the principal, the interest, and the starting balance. We will use the ending balance of month 1 as a starting balance in month 2. In the remaining periods, we will find the interest on the starting balance to calculate interest. We paste this out for 24 periods and find that the ending balance shows we will have $37 to spare, just over $5,000. Now let's use one of Excel's shortcuts. Typing equals future value, we can then enter the applicable monthly rate, the number of months, 24, and the payment. We must enter the payment in a negative form if we hope to get a positive number at the end. Notice, after we calculate it with the monthly rate instead of the annual rate, we get the exact same answer. If we want to find exactly how much we need to save a month, we can use the Excel tool GoalSeek. All we need to do is set the ending cell equal to our goal by changing the deposit, and voila. If we save $198.52 every month for the next 24 months at a 5% annual interest rate, we will have $5,000 exactly at the end of 2 years. You are now equipped to determine your golden nest egg number using the annuity function in Excel. The process is greatly simplified using the payment and present value functions built into Excel. You can use a similar process to calculate what you must save monthly to accomplish this nest egg goal. Now let's see how we can use this concept and apply it to make decisions about our own scarce resources. Hopefully the idea of the time value of money and compounding interest make you think a little harder about the proper allocation of money in your plan of action, your income statement. In this example, 3 coffees each week may not seem like a large amount now, but once the magic of compounding interest is factored in over time, it may make you think twice about your next trip to Starbucks. But beware, you are not the only person out there with a deep understanding of the time value of money. Firms in many different industries will go to great lengths to attempt to use the power of the time value of money against you. One industry that is very good at time value of money calculations is the financial industry, and specifically the credit industry. The time value of money is implicit each time they calculate an interest rate to charge one of their customers. One major component that enters into their calculations that we have not addressed yet is the riskiness of future payments and how likely they are to actually occur. No matter how large of an interest rate the bank charges a consumer, they will lose money if the consumer fails to make his payments. In order to sort consumers into different levels of risk, credit firms rely on a credit score to provide some indication of risk. The credit score is a score between 300 and 850 assigned by the 3 major credit score companies, Experian, Equifax, and TransUnion. The higher the score you are assigned, the less risk you are and the easier access you have to credit. The access includes smaller interest rates and larger loan amounts. Conversely, with a lower credit score, the creditor must be compensated for bearing the risk, and therefore he or she will demand a higher interest rate. In this table, you can see that a person's credit score can lead to a wide range of interest rates, and therefore significantly higher monthly payments. Some of the major factors that can affect your credit score are payment history, or how often you make your payments, amounts owed, what is the total size of your liabilities, and how long of a record you have demonstrating credit worthiness. Looking at the distribution of credit scores across the country, you can see that credit scores are skewed to the right at around 750, but 39% of the population fall on the low credit score below 650. It is important to maintain awareness of your credit score, and there are places online where you can receive a free credit score once each year. Now, back to the bank's calculation of net present value. Most of you probably have a credit card by now and receive monthly statements in the mail detailing your expenditures and requesting a minimum payment that is a tiny fraction of the total balance. What should you pay? Paying the minimum payment will allow you to push paying back what you owe to a later period when the money is worth less. Maybe this is the answer. Wrong. As discussed earlier, banks know these calculations better than you, and 100% of the time they are making money off of you when you decide not to pay back the total balance. If this wasn't true, they would not be lending to you at that rate, but instead they would charge you a higher rate. Not that the rates aren't currently very high, in order to ensure they make money off of you. Let's take a look at this example. Imagine you have a credit balance of $10,000 with an interest rate of 18%. If you only make the minimum payments, you will end up making payments for 15 years and paying almost $6,000 of interest. Instead of making compound interest work for you, you have now become a victim of compound interest. In general, the math does not add up. Surely, educated undergraduates like yourselves know to pay off their entire balance each month. Sadly, this is not the case. As you can see, 29% of undergrads make the minimum payment or less. If you take 2 things from this course, please remember that first, marginal revenue equals marginal cost, and second, and more important, pay off your entire credit card balance each and every month. You are now probably thinking to yourself, I should never trust a bank. And just last lesson, Captain Moore, you encouraged us to take the Cal loan. Surely, USAA, as a profit-maximizing firm, has calculated the present value of the payments and figured out a way to make money off of us. This is true. They have calculated it. Let's look at a regular USAA loan for the same period and loan amount. What gives? The interest rate is almost 9% higher than the interest rate on the Cal loan. Perhaps USA just likes cadets. Maybe. There's definitely no doubt that the present value of your future loan payment is smaller than the $38,500 that you're getting today. But do you think this is the only thing that USAA is calculating when they determine how much you will pay them back? Of course not. They are also factoring in all the future cash flows you will send them during those 5 years as a customer, during which you must have an account with them, and then all the potential future cash flows you will spend with them if you decide to stay past the initial 5 years. The Cal loan is essentially a terrific marketing tactic by USAA to draw in new loyal customers. As far as whether you should take the Cal loan or not, let's compare the total interest for the 5-year loan. For the regular USAA loan, it will be approximately $10,000. Due to this high interest, there's also a relatively high monthly payment. Compare that to the Cal loan, where the total interest is approximately $700 and the monthly payment is much lower. The answer to your question of whether or not to take the Cal loan is all about opportunity cost. If you believe the interest rate that you will receive is lower than the 1% you will pay, then you should not take the loan. Otherwise, our recommendation stands. Take the loan. The time value of money is also important to think about when you think about how you plan to save for retirement. Remember, because it is interest building on itself, small differences each year can add up to big differences in the long run. This is why it is important to consider the effect taxes will have on your retirement savings. We will briefly discuss the IRA as well as the Army's new retirement plan to prepare you to begin saving. The two types of IRAs are the traditional and Roth IRAs. The contribution limit remains $5,500 in 2016 for both of these. Which one is best for you depends on your personal situation, but generally speaking, almost always people of your age will benefit more from the Roth IRA. But first, let's look at the difference between saving in a Roth IRA and saving in a taxable investment vehicle. As you can see, a standard $5,000 a year contribution for 45 years with a 7% return will be $744,000 smaller in the taxable account than in the Roth IRA. That does not seem like pocket change that you want to give up. Let's start with traditional IRAs. The money you place in a traditional IRA can be partially or fully deducted, and it is not taxed until the money is distributed to you in retirement. With the Roth IRA, the money you contribute cannot be deducted, and therefore you pay tax at your current income bracket. The benefit is that this money then grows tax-free and can be distributed afterward without being taxed. Generally, most of you will be in a higher tax bracket in the future than you are currently, which leads to a large tax savings of the Roth IRA. You can start your IRA today because you are all currently making income. All of the major banks and online investing companies offer IRA products to their customers. When you decide who to go with, be sure to consider the fees, as these will eat away at your return in the long run. Finally, one common misconception to clear up is that IRAs are not a type of mutual fund or portfolio of companies that you are invested in. Instead, you can think of it as an umbrella that protects your investments from taxes. You can own the same mutual fund or stock either inside your IRA and underneath the umbrella, or outside of your IRA in the rain, suffering from taxes. Now let's talk briefly about the Army's new retirement plan. As the Army begins to downsize and reduce its large personnel fixed cost contribution to the national defense budget, they have decided to overhaul the defined benefit plan of the 20-year pension and replace it with a defined contribution model much closer to the 401ks seen in the private sector. Due to your projected entry date in the Army, all of you will be forced to take part in this plan. There are a few positives associated with the plan. Number one, it offers you a greater deal of flexibility. You will now be able to leave the Army after your initial commitment and have more than nothing to show for it. Additionally, the Army has decided to match a portion of your contribution each year after the start of your third year. The Army will also pay out a continuation cash payment at your mid-career point. Finally, if you actually do complete the 20 years, you will be entitled to a similar pension as the current one, with the exception that your years of service and retired pay base is multiplied by 2% instead of the current 2.5%. You can opt to receive a lump sum at the beginning of retirement, which will lower your retired pay until 67, or simply receive your defined benefit each month. This concludes this lesson on the time value of money. Next lesson, we will discuss investing basics. Have a great night.